Hello, so today we will be looking at cable television. So cable television started around the late 1940s. It was a better way to provide reception to people who were living in rural and mountainous areas. Initially, it was known as a community antenna television. It did consist of three main parts. So first you had the antenna that sat on top of a hill. The antenna would just pull the television frequency from the air, and then it would be sent to a head end. A head end was just an amplifier that was used to strengthen the signal, and then that signal was sent through a coaxial cable that was placed in, for example, a neighborhood, and then that coaxial cable will be the same that would just carry to each house. But as the demand for the service actually increased, more users were going to impact the performance, and to deal with this, cable operators actually replaced some of the parts with a high bandwidth fiber. The system that was implemented is called the HFC, Hybrid Fiber Coax. So this was pretty much split, one side with fiber and the other side was still using the coaxial. And with this, fiber nodes were placed. So fiber nodes are just electro-optical converters that interface between the optical and electrical parts of the system. So let's take a look to see how this looks. So here we can see now how cable television was set up after the HFC was set. So we have the high bandwidth fiber trunk coming from the head end. This would go through a switch, and from there another fiber line would pretty much carry the signal to a neighborhood. So we can see all these three can be like a neighborhood or a small community, and through there the fiber node would then convert that information from fiber to a coaxial, which would then deliver the data or frequencies to the user. In comparison, it is pretty similar to how it is with the fixed telephone system. So you still have pretty much your fiber trunk. In this case, you have a toll office, and then the line again carried through fiber. You have your end office, but instead of just a coaxial that goes to every user, you have your twisted copper pairs that is dedicated to each house, for example, in a neighborhood. So it is still it's still similar, but again, they do have their differences. So after this, there was an issue that needed to be dealt with, because now that there is television and internet on the same type of line, which is the coaxial line, there needed a way for both of them to coexist peacefully. And with this, the solution was through just spectrum allocation, and the solution was built on frequency division multiplex. So with television, I mean, you do have it's all downstream frequencies. In North America, the way that everything was set up is that usually in the beginning of the spectrum between 5 and 42 megahertz, you have your upstream data where it was allocated to. And then from 54 megahertz to 550 megahertz, this was used for the television frequencies. And with introduction of modems and more modern modems, downstream data could go up into even between 550 and 750 megahertz. Now, with all these, with the internet and the television frequencies still going through the same line, another thing that was updated was in the head end. CMTS, a cable modern termination system, was introduced. This was to help also with the frequencies and the different frequencies between the internet and the television frequencies through this service. All right, so with cable modems, of course, this is needed to access the internet. Cable modems do have two interfaces. So one interface would be between the modem to the network provider, and the other would be from the modem to the user's devices. At first, large cable operators had their own proprietary modems. There was no standard or any really compliance with these modems. After time, the large cable operators teamed up with the company Cable Labs, improves the cable modem standard, and this was used to also make sure everybody passed and the test for compliance regarding cable services. And this standard was called DOCSIS, Data over Cable Service Interface. And here we have an image of how pretty much the data is sent. You have here your cable provider, and you see how in this direction this is going to the modem here on the top. This is the downstream data, and from the modem see some packets going towards the head end and the ISP. This is the upstream data. So there are some differences between ADSL and cable, but again they're still similar. With ADSL, the type of line that is used to provide the service is twisted cable pairs, and it has their own dedicated connection to each user. For example, in a neighborhood, each one would have their own twisted pair line. In cable, it is just one coaxial cable that is shared, for example, in a neighborhood. Um, and this can cause some issues because with cable, if there is a lot of demand through that coaxial cable, since everybody shares it, it existing users can actually have an impact on the performance of their service, especially during like high peak hours. This is not really an issue with ADSL since everybody has their own dedicated connection. Now, with ADSL, there is an issue with distance from the central office that sometimes presents itself. With cable, this is not an issue at all. ADSL is more secure since, again, everybody has their own dedicated line. And usually, in some areas, there are multiple ADSL providers, so the user has a choice between ISP. The only thing with ADSL, it can be susceptible to electromagnetic interference. In cable, this is not an issue, just the way the coaxial cable was engineered. If now the thing is that if the power that's going to the amplifier goes out, like during a power outage, this can cause for the users that depended on that connection, uh, all those users would actually be cut off.